I'm going to look further into integration of trig functions, which like with higher powers and different combinations. So looking at an example, let's say we had sine squared. So the best way I can explain this is for any squared, cosine, or sine terms, use the double angle identity, which we've already proven. You can look in preparation for calculus to see what those are, but I'm just going to write them down. Sine squared is 1 minus cosine 2x over 2, or cosine squared is 1 plus cosine 2x over 2. Then separate the integrals and then integrate. The listening check, color in this entire paragraph. So that's for sine squared and cosine squared. Alright, so replace this with a double angle. So if you replace it, separate the integrals. So it's going to be 1/2 outside 1 dx minus 1/2 outside cosine 2x. Alright, so go ahead and integrate. So integrating 1, you're going to get 1/2 x. And then integrating cosine 2x, well, remember it goes sine minus cosine. Integration goes up. So cosine would be, the integration of cosine would be sine. So you're going to get minus 1/2 and then sine 2x over 2 plus c. Simplifying that, we're going to get x over 2 minus sine 2x. And then the denominators are 2 times 2, which is 4, plus c. That's pretty much it. So let's look at cosine squared. So again, replace it with a double angle formula. Separate the integrals, so 1/2 integral of 1 plus, that's the difference between sine and cosine, 1/2 integral of cosine 2x dx. Alright, then integrate. So integrate 1, you're going to get 1/2 x plus integral of cosine 2x. Again, cosine is going to become sine, so 1/2 sine 2x over 2 plus c. Alright, let's make it neat. X over 2 plus sine 2x and combine the denominators 4 plus c. So that's pretty much it. Alright, so for everything else that isn't in our shortcut, try, and this isn't like it's going to work all the time, that's why I'm saying try. So again, just remind you that all of this is our shortcut stuff, right? So try separating the function into a squared term and leftover. Substitute a trig identity, such as sine squared plus cosine squared equals 1, or tan squared plus 1 equals secant squared, etc. Then use u substitution. Listen, at the end of the day, practice makes perfect. With trig functions, there is no straightforward method, just trial and error. As a listening check, color in this entire sentence in pink. Color in the entire sentence in pink. Practice makes perfect. Practice makes perfect. You have to practice. So let's take a look at an example. Tan squared x. So splitting the function into a squared term, 30 and squared term. So substitute a trig identity. I never remember this one, so I always work it out. I know sine squared plus cosine squared equals 1. Since I want tan, I'm going to divide by cosine squared, getting tan squared plus 1 equals secant squared. So replace that, dx, and then we can go ahead and separate the integral. We don't need to use substitution on this one, so let's say shortcut, because we could use substitution or shortcut, depends on the question. So let's separate the integral. You're going to get secant squared x dx minus 1 dx. Then, so if the derivative of tan is secant squared, integration is backwards, so the integration of secant squared is tan x. And that's in one of our shortcuts, but I'll prove it every single time so we can get used to it. And you write down everything I write down. You miss anything, you don't get your credit. So that's tan x minus, and then the integral of 1 is x plus c. And that's pretty straightforward. Alright, so I ran out of space, so we're just going to make, we're not making another tab, we're just adding a page to it. So let's do tan cubed, separated into squared function. So tan squared times tan x. Then substitute trig identity. So again, sine squared plus cosine squared equals 1. Divide both sides by, divide everything by cosine squared. You're going to get tan squared plus 1 equals secant squared. You need to write that down or I will not give you credit. Alright, so write it in. Tan squared is that times tan squared. Alright, let's go ahead and distribute. So we're going to get secant squared x tan x dx minus tan times 1 is tan x dx. Alright, let u equal secant squared. Well, if I do u equal secant squared, the derivative of secant squared will be secant tan x. So that's not going to help me. So don't do that one. Let's try u equals tan x. So you see it's trial and error a lot of times, right? Derivative of tan x is secant x squared, and that's going to help me. This is a listening check. Circle example 4. Alright, so that's going to be the integral of u, which is tan x, and then du is the whole thing left over, so du, minus, rewrite tan x, and we already know the shortcut to this, but I'm going to work it out every time so I can remember it because I'll keep forgetting. Sine x over cosine x, let u equals cosine x, du equals to sine, cosine, negative cosine, and derivative goes down, so the derivative is negative sine x dx. I need only sine x dx, so I'm going to take divide by negative 1, so negative du equals sine x dx. Alright, so I'm going to get the integral of u du minus the integral of, so u is cosine x, so 1 over cosine x, and sine x dx is negative du, so we're going to change that outside to a positive. Alright, let's go ahead and integrate that. We're going to get u squared over 2 and ln of u, absolute value of u, plus c. Alright, so let's substitute the u's. Be careful which u's or go with which. So that one's tan squared over 2 plus this u was cosine x, so ln of cosine x plus c. That's pretty much all there is to it. Alright, so let's take a look at another example. Let's say you had sine cubed x cosine squared x dx. So go ahead and separate them into a squared term. So sine squared sine x cosine squared. Alright, let's substitute in a trig identity. So we know sine squared plus cosine squared equals 1. So sine squared is 1 minus cosine squared. So we're going to replace that. And then rewrite everything else out just like it is. Let's go ahead and distribute each one of those. So we're going to get sine x cosine squared x dx. And I'm going to separate the integrals at the same time. Minus the integral of cosine to the 4th power times sine x dx, just by multiplying it out. In this first one, let u equal cosine of x, because du is going to give me, let's see, sine, cosine minus cosine. So integral is going, differentiation is going down, so cosine is going to be negative sine x. But I need positive sine x, so I'm going to divide by negative 1. So I'm going to get negative du equals sine x dx. On this one, let u equal cosine, let v equal, so we don't get confused actually. Derivative of that is going to be negative sine x dx, and I need it to be positive, so negative dv is equal to sine x dx. Alright, so let's go ahead and substitute those in. So negative u squared, and then du is negative, so that's going to be negative du, minus v, which is cosine, so v to the 4th, and then dv is negative, so we need to change that to a positive dv. Alright, and integrating that, we're going to get negative u3 over 3 plus v5 over 5 plus c. And now we're just going to substitute what those things are. So u was cosine x, so cosine to the cubed, x over 3, plus v was cosine to the 5th power over 5 plus c. Right, so it becomes relatively easy once you practice. Alright, let's take a look at another one. So again, split it up into a squared function and leftover. So we're going to get cosine squared cosine x. Use the trig identities that you know. So we know sine squared plus cosine squared equals 1. So cosine squared equals 1 minus sine squared. Substitute it in. So now we're going to get 1 minus sine squared x, and then times cosine x dx. Go ahead and distribute it and separate the integrals at the same time. So you're going to get cosine x minus the next integral, which is sine squared x cosine x dx. Alright, well, cosine x, we can integrate that easy. This other one, let's see if we do, let u equals sine x. Du is going to be, so going down, it's going to be cosine x dx, and that's what I want, so that's fine. So now let's put that in. So the integral of cosine x dx minus sine x, which is u, so that's u squared, and then dx is equal to, cosine x dx is equal to du. Alright, so integrating that, we're going to get, so integration is going up, sine x minus u3 over 3 plus c. So we substitute in what u is, so sine x minus sine cubed x over 3 plus. And check underline example 7. Okay, I know this is a lot, but it's just practice. Let's look at one last example. So again, split it up in tan squared and remainder. What trig identity do you know with that? And make sure you're writing all this down, otherwise I don't give you credit. So tan squared x equals secant squared minus 1. Replace tan squared with that. And you're multiplying all of that by tan cubed dx. Go ahead and distribute and separate the integrals. So you're going to get secant squared x tan cubed x dx minus tan cubed x dx. Alright, let's let u in this first integral, let's let u equal tan x. And we know from our shortcut, but even if you don't know, all you got to do is write pst again. If you differentiate tan and you get secant squared x, so this second one, we're going to have to separate it again. So into tan squared again and whatever is left over. So let's do that. So the integral of u cubed du is what I have there, minus, and then we're going to separate again tan squared x and tan x. We're going to substitute in tan squared x. So I'm going to put parentheses so I don't get confused, because now I'm about to split it up again. So secant squared x minus 1 times tan x. Go ahead and distribute it in like we did before. So I'm going to rewrite it. The integral of u3 du minus, put it in parentheses so I don't get confused with the signs. Distribute it in, separate them. So secant squared tan x dx minus the integral of tan x dx. Alright, so let's do some substitutions. I've already used u, so I'm going to use v. So let v equal tan x. That means the derivative of that, using again, the derivative of tan is secant squared x. And then on tan x, we can rewrite tan x, remember, we already know the shortcut, but I'm going to do it the long way. We can rewrite tan x as sine over cosine. We can let w, because I've used uv, I'm just using any letter is fine. W equals cosine x, so then that dw equals negative sine x dx. And we need positive sine x dx, so I'm going to divide by negative 1, so negative dw is that. All right, let's write it all out. The integral of u cubed du minus the integral of v, and then the secant squared dx is just dv, minus the integral of 1 over w, and then sine x dx is negative w squared. So that's going to change the sign on the outside to a positive, and then dw. Okay, let's go ahead and integrate. So u to the 4 over 4, keep the parentheses, v squared over 2. I don't know why I wrote v, make sure you write v squared over 2, and 1 over w is log of absolute value w plus c. Alright, let's plug everything back in. So remember, u was tan x, so that's going to be tan to the 4th power x over 4 minus, and we're going to get in as well, so let's get in minus, I'm going to fix that too. V was tan x, so that's going to be tan squared x over 2, and then negative and a positive is negative, so minus log of w, which is cosine x, plus c. And you can leave your answer like that, or you can rewrite this. So I'm going to write all that out, because if you remember, we can rewrite negative of ln cosine x by taking the negative to the top and then rewriting that as 1 over cosine x, which we all know is secant x. So this way it's positive, in case anyone cares. So plus ln secant x plus c. Both answers are correct, just depends on what they're looking for. And that's pretty much it. So I know this is a lot. You have to practice. You have to practice.